Thanks for joining. We are very pleased to be there. You know, I talked at the FinOps Barcelona last year, 2 years ago, in fact, and it was pretty cool. But this event at San Diego is really crazy. So many things to see, so many insights, great atmosphere. Yeah, it's really crazy. We'll speak about Databricks today. And you know, I'm on the way to get the certification FinOps for AI. And one lesson I've learned during the certification is that we could see some very sudden and very high cost spike. And this is exactly what we have seen, but not for AI, for data processing. And this is a story we would like to tell you today. But first, let us introduce ourselves. So, I'm Philippe Galeano. I'm working for Thales, and more especially a business line called In-Flight Experience. I've been working for this business line as a FinOps for 5 years now. Simon?
Hello, everybody. I'm Simon Prevoteaux. So I work alongside Philippe in the same business line, In-Flight Entertainment. I've been working as a principal data scientist for, I'd say, 4 years, where I've been in charge of building a unique data platform. We were having a lot of troubles. We had a lot of different solutions, data solutions. The data was spread all over. So we came up with this idea of unifying everything. And we picked Databricks as a solution. And I've been leading this project for the last 4 years.
A few words about our FinOps path to begin. We are working with 2 cloud providers, AWS and Azure. And we have launched the FinOps initiative in 2021 with 2 main characteristics. First, we have a very strong support from our management, which is, I think, really essential for a FinOps approach. And second, I have no team but a virtual team, because we strongly believe that FinOps is the job of everybody. So I'm working with a DevOps team, of course, SRE, a marketing team, financial team, etc., etc. And what can I say more? Yeah, we are making 15% of saving roughly per year. About our business line, In-Flight Experience. We are working for the passenger within the aircraft. So the screen you have in front of you as passenger, the screen that allows you to watch movies, to play games, and to access to other services. This is exactly what we are making. That means hardware, software, and a bit of fun. So our main customer, our customers are the main airline company all over the world. And we are based in 4 main countries, Singapore, India, France, as you could hear, and US, not so far from here at Irvine. You could be wondering why we'll speak about cloud for an onboard solution. But in fact, what you should understand, and this is especially the case for our last product called FlightEdge, that this kind of solution is both on board and on the ground. On board, you will find a data center built with similar technologies you will find on the ground, so that we could easily implement any service you will find on the ground, especially OTT services, Netflix, Prime Video, etc., but also other kind of services. We could speak about, I don't know, music, games, or news. Another main component of our system is the connectivity, because we will be able to deploy over the air some new feature or some new services, and also we'll be able to upload some new content, especially movies, similarly over the air. And on the ground, you will find our capabilities to manage overall our solution, to manage the aircraft configuration, for example, and to collect a lot of data from the aircraft. Collect a lot of data to monitor our solution, improve maintenance, but also usage data in order to understand how our solution is used by the passenger. So you have understood, analytics are very important for us. And this is why in 2022, we have decided to build a new data platform. The objective was to structure the approach, to improve governance, to improve security, to reduce time to market, and eventually to reduce the cost. Simon, could you tell us a bit more about this data platform?
Yeah, of course. I mean, as you mentioned, like the system we're providing, they generate a lot of data. So we had to come up with an architecture, and we are not a cloud-native company, so we just wanted to have something simple, something basic. So we're really trying to stick to the standard, to the state of the art. So we're running our platform on Azure, and we use Databricks as the core of our platform. So as you can see, we connect a lot of different data sources. So you see we get stream of data coming directly from the aircraft. We also have a lot of files that are coming because connectivity is expensive, so we don't always get the data during the flight. Some data come after the flight. We also have data coming from databases. So for example, payment data, transactional data. So everything that we have gets then ingested into our Databricks Lakehouse. So we use the Databricks Unity catalog to store and govern everything. And this is where we do our data engineering, right? So we have, this standard medallion architecture. We do bronze, silver, gold. This is where we have all our jobs. We transform our data, and we bring it to I would say, gold layer that then is being used into different, I would say, outputs. Typical one we have a lot of reports. We do dashboards. We have internal reports. We have external reports. We also build custom application for our customers. That we provide for analytics so they can analyze the passenger usage and the performance of our systems. And we also do more and more data sharing, so we have customers that are not only want access to our tools, but they want to access the data so that they can leverage that also on their side. So this is basically what we have. We don't want to go into too much details. Our architecture is pretty standard. But as you can see, there's a lot of different components, and you can imagine that this has a cost, right, Philippe?
Yeah. So here you have the cost per month of this data platform. And first stage, as you can see, the cost was quite stable. I mean, we have been able to implement this new data platform to decommission, of course, the legacy, and to onboard some new data pipeline, all of that at a stable cost. So at this stage, in fact, the result was quite good. But last year, we have started to see the cost increasing. It eventually doubled. Clearly, it was not anymore under control. So just to give you an overview of this cost, they were coming from first the compute part, so Databricks, and second from the storage. By storage, I mean our lakehouse, the Databricks lakehouse called a Unity catalog. Of course, we have some ideas about the root cause. What has changed? First, we have started to use job compute instead of dedicated compute, serverless instead of classical cluster, and we were using already the Unity catalog, but at this date, we have started to use it massively. So we had an idea about the root cause, but no idea how we might solve the problem and take back control. In fact, Simon, we were facing several challenges, right?
Yeah, well, that was probably my fault, sorry. But yeah, as you can imagine, this is a data platform, so the two main challenges we had were over storage and processing. So storage, as you saw on the architecture, we have so many different locations. We use Unity catalog, but then Unity catalog is using Azure storage underneath. So very hard to monitor and understand what your storage cost is actually coming from. Then we use Delta format, right? So Unity catalog is based on Delta, and Delta is a very nice format, but it's also generating a lot of logs. You have retention, you have the time travel capability, and this is adding up on the storage that you are actually paying for, right? And also we are using a premium storage that was recommended by Databricks when we originally set up the platform, and premium storage has a very, very high cost per gigabyte, right? So a lot of challenge on storage, and the cost was super high for us. And then on processing, right? So on processing, Databricks is a very nice platform, but there are so many different, I would say, compute solutions. You have clusters, job clusters, serverless, you have warehouses, you have now Databricks apps. I'm not even to mention vector searches and AI endpoints. We're not going to go into that AI topic for now, right? But a lot of different solutions. You have to be able to monitor all that. They are not always the same, and you can't really monitor them the same way. Processing efficiency is also hard to quantify, right? So you're going to spin up clusters, or the teams are going to come up with a random number, like, okay, I need like 5 nodes. So not so easy to figure out what's the right sizing, what's the right, not instance type that you need to use for your workloads. And finally, observability, right? Like, we had so many things running on Databricks, and we had no idea where it was coming from, what the jobs were doing. So a lot of work on tagging as well to deploy a structured tagging strategy on everything. And just want to mention that also, for a lot of those features, we are really early adopters, right? So we are trying to stick to all the new features that Databricks is releasing, but sometimes it's still lacking some observability, or it's still lacking some maturity, and we are kind of paying the price for that. So now I'm going to deep dive a bit more on the optimization that we came up with, right? Because thankfully, we find solutions, right? So if you can go to the next one, we're going to start with the storage optimization, right? So the first thing we worked on very, very hard was observability. So first thing we looked at was the Azure storage metrics. So we went into Azure, we looked at the metrics from the storage account, and we saw how much data we were storing, right? It was pretty high, and we had an idea of why the bill was so high for us. But then we're still lacking a level of details that could tell us, okay, what table is actually driving this cost? So this is why we had to come up with some Databricks jobs, custom jobs that we've built that are actually running in Databricks, running commands directly on the platform and grabbing the size of the table, right? And then we build on dashboards so we can have our custom reporting at the table level. I'll show you an example right after what it looks like, but it really gives us a very good idea of how much for each table we're actually storing. Not only the active size, but also all the logs and the versions that we're accumulating. Then we could start working on retention, right? So first thing we did was Azure storage. They have a lot of retention, by default 30 days, and actually we didn't need that. So we just removed this thing, made us some saving, and then on the table itself. As we're going to see, there's a lot of, Delta format has a lot of retention that you can set. By default, it's 30 days, and we never, configured it, and we're actually not using it. So then we just updated it to like 0 days or 1 day, depending on the use cases that we had. And this reduced dramatically the amount of data that we were actually storing. Then second thing, it seems obvious, but it was retention on the data tables themselves, right? So what I mean by that is there are a lot of use cases when we start, we have 2 months of data, so we're like, okay, well, we'll see later, right? And then time passes, and 2 or 3 years after, we realize that we're actually keeping all this data from 3 years ago, and we actually don't need that. So again, a lot of work on setting up jobs to actually go and remove some old data from our tables to also reduce the amount of data that we're storing. It's even more important if you do that, because all the retention that you have is adding up on the cost. And if you are doing some stuff like materialized use, you're going to store, the version of your tables are going to be the whole table. So if your table is super big and you do materialized use and you store versions of your table that are the whole data set, if you have a 5 gigabyte table, you can actually store 200 gigabytes in your storage account, right? So if you can get to the next one, this is a dashboard that we've built. So it's a custom one we've done, but you rely on the commands that have been provided by Databricks. And what you can see actually is like each bar or each row actually represents a table. And you can see the active size in blue, which is actually what you are using. And then in yellow, you can see the time travel size. So it's actually all the versions that you are storing so that you can do time travel on your tables. So as you can see, it can get pretty big compared to your active size. And then you have vacuumable size, which is actually I would say the time travel logs that are not used anymore, that can be deleted, right? And Databricks, they have an automatic vacuum that's supposed to happen, but sometimes, depending on your tables and the cases, it doesn't happen. So you're actually storing data that's actually completely useless. So this is all kind of the stuff we looked at, all the optimization we did on storage, and Philippe is going to show you what we ended up having in terms of saving.
So in terms of equipment at this stage, we have been able to reduce the cost by 56%, which is quite good, knowing that at the same time we still have a lot of pending action. So this is not finished. Now, about the processing part. As Simon said just before, our first issue was around the reporting. Not enough details. For example, we didn't have the allocation of the cost per product, per Thales product. So we had to improve this reporting. And when we speak about reporting, we should speak about tagging. Of course, tagging the resource was not enough. because we were using some shared resources. So we had to tag the pipeline and the job themselves. And the first step was also to define what will be our tagging strategy. So you have here, let's say, a classical data processing chain. And we have decided to divide this chain in two. On one side, the bronze and silver data and the associated processes. And on the other side, the gold data with, again, the associated processes. Why? Because the nature of this data is very, very different. For bronze and silver data, you will find high volumes, and the calculation around this data are quite simple, mainly ingestion, in fact. And at the opposite, for gold data, you will find lower volumes and more complex calculation. And another thing is, most of the case, bronze and silver data will be used several times to calculate different KPIs. At the opposite, again, for gold data, most of the case, you will use them only once to be published on one dashboard. So for bronze and silver data, we have decided to implement two tags, a phase, ingestion, and a product. In fact, the Thales product who has generated the data. And for gold data, we have, again, two tags, phase, aggregation, and what we call a publisher, which is the Thales product who will publish the data. And for some cases where the KPI is calculated specifically for a customer, we could have also a customer tag. So we have defined this tagging strategy with, of course, the DevOps team, but also with the product manager in order to be sure that everybody will speak the same language. So once we had this tagging strategy, we have started to implement it. And as you can see here, so this is the cost per publisher and per month. We have started to see some reallocation of allocation of the cost. And we have been able to identify what was the most expensive one. And more than that, our reporting tool allows us also to have the details per pipeline. And surprisingly, we have seen that on this publisher, the main cost was coming from 3 main pipelines. So we had to investigate on these 3 pipelines. And this is where, in fact, at this stage, a technical dashboard was required.
Yeah, and I mean, as Philippe was showing, we're using Datadog for cost monitoring, right? And what's very interesting is that we're able to go from the higher level, which is the product view that we have, and then we're able to deep dive and go even to the pipeline level and have those kind of a deep, detailed view where we can actually see for one job or one pipeline actually how much CPU is being used, if you have idle CPU and stuff like that. So for us, it was really interesting to be able to actually go from the, the most costly products or stuff that was running, and then go down to the pipeline and actually see if we are using resources properly, if we are able to downsize or maybe change instance types or stuff like that. So now I'm going to talk a bit more about the processing optimization, right? So the dashboard you just saw was really helpful to help us achieve those kind of things, right? So again, observability, like storage, before you can do anything, you need to understand what's actually going on. So we use Datadog a lot for our cost monitoring. We use it not only for Databricks, we use it for everything else, which allows us to have like a broad view on everything that we do. So not only Databricks part, but also for the global product. A lot of work on tagging. Databricks is very convenient. You can add tags, but you have so many different resources between jobs and clusters. And if you do serverless, you have to do budget policies to apply your tags. So tagging is a very long activity. You have to come up with the design, and then we have, I don't know, 30, 40 different source code repositories. So you actually have to go. We use Terraform for automation, so you have to go and update everything. Now, thanks to AI, it's a bit easier, I guess. But when we started that, we had to go manually update the tags of all the jobs. So it's very tedious, and it's a very time-consuming process. But you need to do it before you can do anything else. Then on the performance side, the things we did to optimize and reduce our cost. First thing is like we move a lot of workloads to serverless. We had a lot of small jobs where we were just like querying an API or triggering some small activity, right? So this we all moved to serverless, and this really drastically reduced our bill, right? Then we mentioned that already in the storage optimization, but we reduced the amount of data that was being processed, right? So if you reduce the amount of data, then for sure your processing is also going to reduce because your jobs are going to run faster or take less time to complete. A lot of stuff we also start looking into was optimize the cluster sizes, right? So we had teams who were building a new project, and they were using the default node type or instance type, and they had no idea how to come up with that. So we actually spent a lot of time going and looking at the ratios between CPU and memory, and we realized that for some of the workloads were very memory intensive, and actually the CPU was not being used, and sometimes was the opposite, right? So if you pay attention to that, you can actually go and find instances that are more optimized for the workloads that you are actually trying to do. So again, a lot of optimization, and Philippe is going to show you the results of all this work.
When I see Simon speaking, I realize how his job is technical. I mean, there is so many parameters, and this is not so easy to find which one could help us to optimize the cost. This is true, but at the same time, I strongly believe that with very simple principle, something even me could understand, we could already find some great saving. And I would like to show you an example on one pipeline we have optimized. First, the data period. In fact, most of the case, we are collecting the data from the aircraft. That means that to calculate an accurate KPI, we need to wait the end of the flight in order to have all the data of this flight. And even that could not be enough, because we could have some connectivity issue, for example. So we have to wait a few days to have the full view on this data. That means that, in fact, we couldn't just take the new data to calculate a KPI. We should go back in the past. And when you are a DevOps guy, as your main objective is to calculate an accurate KPI, you are going to go back a long way in time. And in our case, they have taken 1 year. So, in fact, we have just reduced this data period from 1 year to 7 days, and thanks to that, we have been able to divide the cost by 8. Second example, the frequency. We know that the frequency on which we launch the pipeline could have an impact on the cost. On that case, the frequency was every hour. So of course, I've tried to challenge the DevOps team on this frequency, and they told me that it was not possible because of the customer SLA. So I had a discussion also with the product manager, and surprisingly, there was no customer SLA. And more than that, the dashboard on which this KPI was published, was used only once a week. So again, first stage, we have reduced the frequency from every hour to twice a day. And again, we have been able to divide the cost by 2. So to sum up, don't hesitate to challenge the team on these points. Often they haven't thought about it, despite the fact that the impact on the cost could be very significant. So now, about our achievement on the cost. So first, on the focus on the compute part. So at this stage, we have been able to save 42% of our cost. And now, take a look at this overall picture of the data platform. We have been able to reduce the cost by 43%. That means that, in fact, we have been able to recover a cost which is quite similar with what we had previously, knowing that at the same time, of course, we have onboarded some new data pipeline. So the results are quite good. So just to sum up, what we have done to achieve that. First, we have improved the reporting. Second, retention rules. We have put some retention rule at the database level. Then we have optimized the cluster size. We are using smaller jobs, and we have played with frequency and data period. I would like to highlight 3 points as takeaways. First, to get this saving, we have worked with architects, SRE team, DevOps team, product manager, third party, Azure, Databricks. We wouldn't have been able to make those savings without this guy. So clearly, I mean, collaboration for FinOps is essential. Second, clearly we have lost a few months because our reporting was not efficient. So I really think that we should build a cost reporting very early in a product life cycle. And this is why, even if my consumption is quite low at this stage, I'm already working on a cost reporting for AI. And last point, we have made some great saving, and we are quite proud of that. But this is not the best part of the story. I mean, we have prepared the future, because now we know how to optimize pipeline and jobs. We have an efficient reporting. We have some data retention rules on the database. So now we know how to build some new data pipeline at an optimized cost. And last point, we can also now estimate more easily what will be the cost of the future pipelines. And in fact, we are trying to work similarly on other kind of services, so that now what we are doing is that for each new product, we are building what we call a costing model. So you have here's the example for FlightEdge, the product I've presented to you just before. So the idea is based on business assumption. So here it would be the aircraft fleet size, the catalog of content, so the volume of movies, the renewal rate for this catalog. So based on this business assumption, we could estimate what will be the cost of this solution per customer and per aircraft. This is, of course, very useful for RFPs, and I'm working with the marketing team on that. But also, with this tool, based on signed contract, I could easily also estimate what will be the forecast for the next year. That's it. Just a few words about now the next step. First, the analysis, we have not finished, in fact, the analysis on the product, so we should continue this analysis. And we are expecting this year 20% of additional saving on the compute cost. Second, so we have improved the reporting for the compute part, but now we should also improve the reporting for the database, again, to understand where there is some saving opportunities.
Yeah, I think on this point, I just wanted to add something. And it's true that more and more features are also being released by Databricks. And I think we can rely on that on the future as well. And this is going to help us a lot to, again, drive our cost, optimize our cost a bit better. Something else we want to put in place is actually some kind of a cost governance, right? So when we have new teams building products, sometimes they pay attention to those rules that we're trying to define. Sometimes they don't. So they end up creating jobs that are not tagged, resource not tagged, and they don't set the retention as we want to. So we want to start having like jobs that are actually running and checking those rules, making sure that everything that is being deployed and built on our platform is actually meeting our standards, right? So this is something very important for us, and we want to really get to that point. And finally, one thing that we really want to do, but it's actually much harder than we expected, is actually migrate from the premium storage account to the standard one. Again, the savings we expect is 80%. Premium is a bit more expensive on storage, but it's cheaper on latency. Standard is going to have a bit more latency, but we don't do that much streaming jobs. So for us, the cost of storage is actually pretty big. Moving from, once you have built your whole lake house on the storage account, it actually moving all your tables to a different one is actually a huge work. We have so many different jobs. We use DLT as well. So there's a variety in the tables that we're using. And we started working with Databricks on this one. And we hope that we're able to find a solution to do this lift and shift to standard storage account. I think that concludes our talk. I hope you guys liked it. If you have questions, feel free to raise your hand. And if you want to discuss after the talk, we'll be hanging out in the expo. And if you want to deep dive on this, we're happy to talk, right? Thank you, guys.
Any questions, guys? Anyone needs a cube?
When you were going through this transformation, how did your data engineers take this change?
I think it was well received, I would say. I think the hardest part is to actually get this prioritized. Like, because we have like program managers or product that are pushing for their roadmap, right? So being able to kind of take bandwidth on the data engineers and I would say more broadly on the development team to start implementing tagging and going on all jobs and re-optimizing. Sometimes you have to upgrade the runtime, so it's breaking things, so it's taking some time. So it was mostly well received by the developers, but it was more like program managers that were not always seeing the value and more like, okay, guys, do we really have some time to do that? So this is where Philippe is very important as the FinOps manager to go and talk to those guys and explain to them that this is actually something very important that you need to take care early. And otherwise, if you keep building, the cost is going to grow exponentially, and you're going to, be in real trouble. So, but it was well received, I would say, in the overall.
Yeah, I think, in fact, it's the main job of the FinOps to be sure that everybody understand that the cost is part of their responsibility. In fact, so yeah, so it's I'm working for that for a long time. I mean, to be sure that the DevOps team understand that, and I mean, when we give them some tools to see the cost and to see what they could save in term of cost, then I think it is like a game. I mean, when they see that they could have a great impact on the reduction of cost, they are quite proud of that. Yes.
Thank you.
Decrease the cube.
Can you hear me okay?
Yeah, we can.
I've got two questions. One is, you look at compute and the storage cost. Did you look at it from a unit economics context point of view as well? Has it gone down? Has it gone up? And second, did you do anything on the query side as well? Because queries can drive a lot of cost.
Yeah, I mean, we definitely looked at the warehouses, but more from a global sizing. We looked a little bit on queries, but not that much. There's a couple topics we have left on the table, is queries and network as well, because we do some for delta sharing, for example. Sometimes we do multi-region, so we have egress costs as well, which is might become a big concern. But we really focused on the two big ones, which were for storage and compute. But queries, not that much. I guess our gold layer is actually pretty small. We get a lot of data, but then once it's being refined, it's actually decent. I mean, the size is actually pretty okay. So on the reporting side, where a lot of queries are being executed, the cost is actually not that crazy. We use actually decent-sized clusters. The number of users that we have is not so high. I mean, we don't have like tens of thousands of users. It's actually, a couple airlines. And so we didn't really have a problem on the query optimization. Then on the unit, maybe you can answer on this one.
No. You meant on the unit economics?
Yeah, on the unit economics.
No. I think we didn't make a focus on that for the moment, because yes, this is not the main cost. About unit economics, we are working on unit economics, but not really for the moment on Databricks especially. Yeah.
Maybe one thing we can mention, actually, the example you gave me a couple days ago was we realized that we use serverless for the warehouses, and we realized that we had with SQL warehouses that were staying up, right, all the time, and they were serverless. So we actually went and we looked at the queries, and we see no queries. And we realized that the team, they were keeping the connection open. So actually, the benefit of using serverless, where it's going to shut down and then spin up again, was actually lost, right? Because we had like a lot of idle consumption on those warehouses. So we still have some work to do on this part of the thing, but I mean on the work. But yeah, overall, this was not our bigger concern.
Thank you.
throw it there. Don't hurt anyone.
Right.
Okay. I'm not sure if you can go back, but on the stack bar chart you guys were showing about your cost optimization, you had storage and compute. I noticed the smallest kind of color there was the green one, legacy. I was wondering if you could speak a little more to that kind of path.
Yeah.
And I didn't know if that was like, so the green path right there.
Yeah.
I was kind of interested in what that kind of entailed. So.
Yeah. So yeah, we still had a bit of legacies. Yeah, so we have at the same time we have decommissioned it. Yes.
Okay.
But there is no link directly with what we had in Databricks.
Okay.
Yeah, legacy, for example, I can give you a couple examples we had. Was the big one was Hadoop, with Hadoop clusters that were still running. So we migrated everything from Hadoop to Databricks. It was a big cost saving. Another one, we had a lot of custom stacks on MongoDB that we also try to move to Databricks. And I think it's part of what we say it's legacy, right? So it was more part of all the old data solutions that we're having. Took us sometimes to get to everything in Databricks. I think we're still not there completely yet. For a couple things still running. But then it depends kind of we have some programs that for some certain airlines are going to finish in 2 years. So, the effort of migrating to the new data platform is also a big, I would say you need to think about, your customer, the programs, the due date of those programs, because sometimes it's just not worth it.
Yep.
Costs a lot of money and effort to do it, so.
Cool. Thank you.
Hey everyone, producer Andrew here. Thanks for watching. Check out the rest of our channel for more FinOps content. Like, subscribe, and leave questions and comments for our speakers. We appreciate your support.